Ever wondered how developers keep track of every change they make and never lose their work? That's where Git comes in. It's like a time machine for your code, letting you jump back to any moment in your project's history, work with others without chaos, and avoid the dreaded overriding panic. In this video, we'll break down Git into simple, beginner-friendly steps so you can start using it with confidence. Let's get started. First, let's take a look at what Git and version control are. Version control is a system that records changes to files so you can review, compare, and restore previous versions when needed. Git is the most popular version control system, and it works locally on your computer. It stores a complete history of your files, letting you branch off to try new ideas, experiment without fear, and merge your work back in when you're ready. This makes it almost impossible to lose progress, and it's a lifesaver when you're working with others. You might have also heard about GitHub, but don't confuse the two. GitHub is an online platform that hosts Git repositories, making it easy to share your work, collaborate in real time, and contribute to projects from anywhere in the world. Think of Git as the engine and GitHub as the garage where you keep, showcase, and maintain it. Together, they form the backbone of modern software development. Now that we know what Git is, let's get it installed so we can actually start using it. On Windows, head over to git-scm.com, download the installer, and follow the setup wizard. On Mac OS, the quickest way is with Homebrew. Just run brew install Git in your terminal. On Linux, use your package manager, sudo apt install Git for Debian or Ubuntu, and sudo dnf install Git for Fedora. Once installed, type git-version to confirm it's working. You should see something like this. Before you start testing commands, it's important to set your name and email so Git can label your commits correctly. You can do this with these lines. These settings are enough to get started and try out Git without running into issues later. Before we dive into Git commands, let's quickly look at the core concepts you'll need to understand. Git starts with the repository, where all your project history lives. A commit records changes, while the staging area lets you prepare what to include. With branches and merges, you can experiment and bring work together. Remotes connect your project online, and with clone, push, pull, and fetch, you keep everything in sync. You'll also use checkout or switch to move around, with head showing where you are. Tags mark important points, and .gitignore helps you keep unwanted files out. We'll now explore each of these step by step. In general terms, a repository is simply a storage location where project files are kept. What makes a Git repository different is that it doesn't just store files. It also records a complete history of changes, including commits, branches, and merges. Every Git repository has a hidden .git folder, which holds the metadata and objects Git needs to manage version control. You don't need to inspect this folder yourself. Just understand that it's what enables all of Git's features to work behind the scenes. This allows you to track changes over time and move between different versions of the project. In short, a Git repository is more than a storage space. It's the backbone that enables Git to manage your project's evolution. A commit acts as a snapshot of your project at a particular moment in time. Every time you make changes that you want to save, Git takes those modifications and stores them as a commit, almost like adding a new page to the project's history book. A commit doesn't just save files. It also records important details such as the author, a timestamp, and a short message describing what changed. This way, you can clearly understand why certain changes were made and by whom. Over time, commits build up into a chronological chain, allowing you to look back, compare versions, or even roll back to an earlier state if needed. In short, commits are the building blocks of your project's history in Git. The staging area in Git acts like a preparation zone for your changes before they officially become part of the project history. When you edit files, those changes don't immediately go into a commit. Instead, you first add them to the staging area, where you can carefully select which modifications should be included. This gives you control to group related changes together and keep your project history clean and organized. For example, you might update multiple files, but only stage the ones that belong to a specific feature or bug fix. Once everything you want is staged, you commit them as a single, well-structured snapshot. In short, the staging area helps you organize and polish your commits before they're saved. Branches in Git are pointers to snapshots of your project, allowing you to develop features, experiment, or fix issues in isolation without affecting the main code base. When you create a new branch, Git makes a lightweight copy that starts from your current commit, meaning you can make changes independently while keeping the original branch untouched. This separation is useful for team projects, where each developer can work on their own branch and later merge their work back into the main branch once it's reviewed and tested. Common workflows involve having a dedicated main branch for production-ready code and additional branches for new features, bug fixes, or experiments. After working on a branch, you'll eventually need to combine your changes. That's where merging comes in. When you merge a branch, you're bringing the changes from one line of development back into another, like merging the feature login branch into main. Most of the time, Git can combine the code automatically, saving you the work. But sometimes, if two branches change the same part of the code in different ways, Git won't know which version to keep. That's a merge conflict. It's then up to you to resolve it, choosing or rewriting the code so everything fits smoothly into the project. When working with Git, your local machine isn't the only place where your code lives. The repository stored online, often called origin, acts as the central hub where your project is shared and synchronized. This could be on GitHub, a cloud server, or even a shared folder in a team environment. You push changes from your laptop to this origin so others can access them, and you pull updates to stay in sync with your teammates. In short, origin is the common meeting point that keeps everyone's code connected. While adding a local directory to GitHub makes it available remotely, cloning works in the opposite direction. It creates a full local copy of a repository that already exists on GitHub, including its files, commit history, and branches. This allows you to explore the project structure, review past changes, and continue development on your own machine. The local copy remains linked to the original repository, so any future updates can be synchronized between your computer and the remote source. After cloning a repository, the real collaboration begins with the pull, push, and fetch cycle. Pull is like bringing the latest changes from GitHub down to your computer, ensuring your local project matches what others have been working on. Push works in the opposite direction. It takes your local changes and updates the shared repository so everyone else can see them. Fetch is a little different. Instead of directly updating your files, it simply checks the remote repository and tells you if there are new changes available. Together, these three actions keep your local project and the remote repository in sync, while giving you control over when and how updates are shared. Checkout and switch let you move between different branches of a project, choosing exactly which line of development you want to work on. By selecting a branch like Feature Login or Bugfix Header, you step into that branch's current state, seeing its code and making changes independently of the others. This is especially useful when working in a team, as each member can explore or update separate branches without interfering with the main project. Now to something tied directly to checkout. Head, your pointer in Git's timeline. Head is like your compass. It always points to where you currently are in the project's timeline. If head is set on a commit like replace old logo, that means this is the version of the project you're actively working from. You can think of it as a small marker that says you are here. When you switch branches or move between commits, head shifts along with you, making sure Git knows your exact position. Whether you're looking back at history or making new changes, head keeps you oriented so you're never lost in the chain of commits. Now that we've seen how head moves along the commit history, let's look at something that stays put: tags. In Git, tags act like bookmarks or sticky notes you attach to a specific commit. They don't move forward with new changes. Instead, they mark an exact moment in time, often used for releases like version 1.0 or version 2.3 latest. Think of them as stars or labels that highlight important milestones in your project. For example, even if head has moved to a newer commit, the tag version 1.0 demo still points back to that older version, making it easy to revisit whenever you need. Now let's talk about gitignore, a small but very useful file in Git projects. Its purpose is simple. It tells Git which files or folders should be left out of version control entirely. This is especially important for things that don't belong in your shared history, like automatically generated build files, system-specific clutter, or sensitive information such as passwords and API keys. A typical gitignore might include entries like env, log, or conf. By keeping these files out of your repository, you avoid unnecessary noise, reduce security risks, and ensure that your collaborators only see the files that are truly relevant. In short, gitignore helps keep your project clean, secure, and easy to manage. Now let's move on to practice. To create a Git repository, there are two main ways to start. You can create a brand new repository inside an existing project folder with the command git init, or you can copy an existing repository from a remote source, like GitHub, using git clone, followed by the repository link. You'll find this link on the repository page on GitHub, usually under a green code button. With git init, Git sets up a hidden .git folder that turns your directory into a fully tracked repository. With git clone, you get not just the files, but also the project's entire history, so you're ready to start collaborating right away. In short, whether you initialize from scratch or clone from the cloud, this is the very first step toward managing your code with Git. Now it's time to talk about how Git actually keeps track of changes. This process revolves around three commands: git status, git add, and git commit. We'll start with git status. Let's say you've just created a file named index.html. When you run git status, Git shows you exactly what's going on inside your repository. The first line tells us that we're on the main branch. Right now, that's the only branch we have. The next line, no commits yet, reminds us that we haven't saved any changes into Git's history. Finally, under untracked files, we see index.html. Git can see that this file exists, but since it hasn't been added yet, it's not being tracked. Git knows the file is there, but unless we explicitly add it, it won't be included in our project's version history. To add files, you use the git add command. This tells Git to move changes from the working directory into the staging area, a kind of clipboard where you prepare everything you want to include in your next commit. For example, running git add index.html updates the status. Now Git shows the file under changes to be committed, meaning it's ready to be saved into the repository. If you want to stage all new or modified files at once, you can use git add followed by a dot. In short, git add bridges the gap between just having changes and actually recording them in Git. Once your changes are staged, you use git commit. This line saves a snapshot of your project. The output helps us understand what just happened. The first line shows the branch name, that this is the first commit, indicated by the root commit label, the unique commit hash, and the commit message itself. The next line tells us how many files were included and how many lines of code were modified. Finally, the third line indicates that a new file was created and is now being tracked by Git. A follow-up git status confirms the working directory is clean, meaning all changes are safely recorded. In the diagram, the highlighted arrow shows the movement from the staging area into the repository, illustrating how commits capture a permanent snapshot in your project's history. Now let's talk about viewing history. To view Git history, you can use the git log command. Git log gives us a list of commits, showing who made the changes, when they happened, and the messages describing them. In this example, we see the initial commit followed by the one that added the homepage layout. Of course, this isn't the only way to view history in Git. You can also use additional options, such as the one-line flag that condenses each commit into a short summary, which makes it easier to scan through many changes. With stat, Git shows which files were modified and how many lines were added or removed, while p lets us dive into the actual code changes. Other useful options include graph for a visual branch structure, all to see the history from every branch, and filters like author to narrow results down to specific contributors. These variations let you choose the right level of detail depending on what you're looking for. Now let's move on to one of Git's most powerful features, working with branches. By running git branch, you can see a list of all available branches, with the asterisk marking the one you're currently on. In most modern repositories, that default branch is called main, but in older projects you'll often find it named master. Functionally, they're the same, just different naming conventions. To create a new branch, you can run git branch followed by the branch name, which simply adds it to the list. But notice, you'll still be on the main branch until you explicitly switch with git checkout. If you want to create and switch in one step, you can use git checkout with the b flag, which saves you from running two commands. Git later introduced the git switch command as a more intuitive alternative, separating branch operations from other uses of checkout. You'll often see Git Switch or Git Switch-C used in the same way as their checkout equivalents. Once you've modified the code and your work is ready, you typically return to the main branch with Git Checkout Main and merge your changes back in. That will add changes from the specified branch into the one you are currently working on. If Git can combine the changes automatically, you'll see a fast-forward update, like in this example where a file gained 5 new lines. But if there are conflicting edits in the same part of a file, Git will flag a merge conflict. You would then have to manually tackle those conflicts by telling Git which version to use. You can resolve merge conflicts using visual tools built into most modern editors, such as VS Code. After merging, your feature branch isn't deleted. It still exists and can be reused or removed later, while all of its changes are now part of the main branch. Up until now, we've been working locally on our own machine. But to collaborate effectively, we need a remote repository. First, you create one on a platform like GitHub. Then, you connect your local repository to it using a name like Origin, which is simply a conventional alias Git uses to refer to that specific remote repository. You can verify this link to see both the fetch and push addresses. Once connected, you can use 3 key commands. Push, which moves your local commits to the remote repository so others can access them. It ensures the remote reflects your latest changes. Pull brings down commits from the remote and merges them into your current branch. This keeps your local branch up to date with changes from collaborators. Fetch downloads new commits from the remote without merging them immediately. It lets you inspect changes before deciding how and when to integrate them. Together, these commands extend everything we've learned so far, taking local history and branches and turning them into a shared timeline for the whole team. Now let's move on to undoing changes. If you change a file but decide you don't want those edits anymore, Git Restore resets it back to how it looked in your last commit. If the file was already staged, Git Restore stage takes it out of the staging area, but keeps the actual content in your working directory. Older tutorials may still use Git Checkout for this, but Restore is now the newer, clearer, and less ambiguous command. And if you want to move the project back to an earlier point in history, Git Reset shifts head to that commit. By default, this unstages everything but keeps your files so you don't lose work. Git Reset also has some stronger options you can use. Git Reset soft moves head but leaves your files staged, ready to recommit. Git Reset Mixed is the default, keeping changes in your working directory but removing them from staging. Git Reset Hard goes further by erasing both the commits and the file changes, so use it with caution. Sometimes, instead of rewinding history, you may want to safely cancel a past commit. Git Revert does exactly that, by creating a new commit that undoes the earlier one, preserving history. And if you just need to fix your very last commit message, Git Commit Amend lets you rewrite that most recent commit without affecting anything else. Now that we've explored the key concepts individually, let's put them together into a simple Git workflow. Let's say you've opened up VS Code and initialized a Git repository for your project. As soon as you start editing files, Git notices these as local changes. From here, the typical workflow begins. Local changes can be filtered by a gitignore file so unnecessary files don't clutter your repository. When you're ready to track progress, you add your work to the staging area, preparing it for the next step. A commit then takes a snapshot of your project's state and head marks which commit you're currently on. Commits can be shared with others by pushing them to a remote repository like GitHub, where you can pull updates made by teammates. Along the way, you may create branches to experiment with new features or add tags to mark important milestones. This cycle from local edits to collaboration through the remote forms the foundation of Git's workflow. Now let's quickly take a look at common mistakes when working with Git. Even though Git is powerful, it's easy to make mistakes that cause problems later. One common pitfall is writing vague commit messages like fix stuff or update, because when you look back weeks later, it's impossible to know what was really changed. Another issue is forgetting to add a gitignore file, which can lead to clutter from log files, editor settings, or build artifacts being tracked unnecessarily. Adding large files, such as videos or executables, is also a mistake, since Git isn't designed for that, and the repository can quickly become slow and difficult to manage. Skipping a Git pull before pushing is another trap, as it often results in conflicts when your local work doesn't match what's already on the remote. Finally, Using Git reset hard without fully understanding it can wipe out valuable work with no easy way to recover. Avoiding these mistakes not only keeps your project clean, but also saves you and your collaborators from unnecessary frustration. In conclusion, we've covered the core concepts of Git, from making local changes all the way to working with branches and remotes. But this is just the beginning. Git is a huge tool with many more commands and workflows than we could fit into one video. Git isn't just a tool for code. It's essential for managing any technical project, whether it's a small personal script or a large team-based software system. The best way to really understand it is by practicing. Create small projects, try out different commands, and experiment with branches and remotes. And when you want to go deeper, the official Git documentation is an excellent resource with clear explanations and examples. The more you use Git, the more it becomes a natural and indispensable part of your workflow, helping you stay organized and collaborate effectively. This brings us to the end of our journey through Git and its essential commands. If you enjoyed this video and want to keep learning, be sure to check out the other topics on the channel. You can also follow us on Facebook and Instagram for more updates. Thank you for watching.